Okay, Assalamualaikum and a very good day to all. So we are going to discuss chapter Newton's law of motion, and this chapter separate into two parts, which is the first one going to be just concept, and second one is more to the how we are going to cooperate different force into our free body diagram. Let's start. Okay, so before we discuss about free body diagram, definitely we need to understand the concept behind Newton's first, second, and third law. Okay, so when it comes to the force, okay, when you have force is basically something that you push or pull, okay, and force going to change your direction and your magnitude. Okay, it's going to change your direction and your magnitude. So means that without force, what happen is your direction and magnitude will not be changed. Okay, will be constant. Okay, so force is basically a vector, which means that you have a magnitude and direction. So we are going to consider the directions positive and negative of force. Okay, once you incorporate force into your calculations, definitely it's compulsory for you to find the magnitude and direction. So example, if you get your answer negative, then you need to state negative means what? It's moving to the left or it's moving to the right. Okay, it depends on your assumption. Okay, so the first one going to be Newton's first law. Okay, so according to the Aristotle, the natural state of an object is to stay at rest. That's why another name for the Newton's first law going to be inertia. But what does inertia means? Okay, inertia means that if example you have one object, okay, you have one object, this object will stay at rest, or this object will move with the constant speed unless acted by the unbalanced force. Like I mentioned before, once you have force, you are going to change their magnitude and direction. So for the object to be at rest, it means that we can actually say that there's no force acting on it, or we can actually say that the net resultant force going to be zero. Okay, or example, if your object moving with constant speed, we can say that the resultant or the net force equals to zero. What happened is you have a force, but your net force going to be zero. That is Newton's first law, the tendency of an object to stay at rest or moving with constant velocity unless you have unbalanced force acting on it. Okay, so basically what happened here is that's why we can call it as a law of inertia. Okay, another name for the Newton's first law is law of inertia. So what happens is the definition of Newton's first law you can actually rephrase, but the meaning, the concept is still there. Okay, so the object will stay at rest or moving with constant velocity unless acted by the unbalanced force. Okay, that is Newton's first law. Okay, and that's the reason why for this one, okay, example, if you push the trolley and suddenly the trolley stop moving, definitely you have unbalanced force, which is why it stop moving, because we have a friction. So basically what happened here is we have two types of friction. We have static frictional force, we have kinetic frictional force. That one going to be discussed in the next chapter. Okay, so if example there's no force, means that you push the trolley on top of frictionless surface. What happened? The trolley are going to move with a constant velocity and continuously moving without stop. But example, if suddenly your trolley stop moving, it means that definitely there will be a unbalanced force, and that unbalanced force can be stated as a frictional force. Okay, so this one going to be discussed in the next chapter. the directions of frictional force, and so on. Okay, so now we only discuss about what is Newton first, second, and third. So that's why for this one, every object continues in its state of rest or at uniform velocity as long as no net force acting on it. Okay, so even you have one unbalanced force, still you are not going to move in a straight line, or you are not going to move in a constant velocity, and you are not going to be at rest. Okay. Okay, so what happened here is this is like one of the everyday applications that relate with the Newton second law and Newton first law. So you can actually see that there's the reason why you need to wear a seat belt. If you didn't wear a seat belt, what happened is you are going to move forward with the velocity of the car itself. Okay, because the object tend to stay at rest, or object tend to move with a constant velocity. So now you are going to move with the velocity of the car. Because without the seatbelt give you some force to hold you inside the car. So without a seatbelt, it means that you are tend to move with the constant velocity of the car. So that's why we call it Newton first law as the law of inertia. Okay. Okay, so this is one of the conceptual questions. A school bus comes to a sudden stop and all of the backpacks on the floor start to slide forward. What force causes them to do that? So what force causes this backpack to move forward? There's no force. Okay, what happened is, if we have a force, definitely the object will accelerate, or definitely the object or the backpacks will stay at rest. Why is going to stay at rest? Because you have a friction, or you hold the backpack, which means that you give some force. By example, for this one, the backpack is start to slide forward, means that there's no force hold the backpacks, and the backpacks will move with the velocity of the school bus. So this is one of the questions that relate with the Newton first law, and this is the reason why we say that is because of inertia. Is going to move forward with the constant velocity of the bus. Okay. Okay, so we move forward with the Newton second law. Okay, so like Newton first law is without force, so you are going to move with the constant velocity or stay at rest. But this one, if you have an acceleration, definitely you are going to have force. Okay, which is net force. Okay, because why? Like I mentioned before, force change the magnitude of the velocity. So when you have changes in terms of velocity, it means that you are going to have an acceleration. So the acceleration is directly proportional to the net force applied, inversely proportional to the mass. So that's why it's going to be related by F equals to ME. Acceleration is directly proportional to the force, inversely proportional to the mass. Okay, and then you need to take note that the direction of acceleration will follow the direction of net force applied. So example, if you get your answer net force positive and you assume positive is to the right, it means that your direction of acceleration also to the right. Okay, so Newton's second law basically relates the acceleration, the force with acceleration, which means that in moving object. Okay. Yeah. Okay, so mostly for these questions, we are going to relate in FBD, in the free body diagram, which I'm going to explain later. And this is one of the questions where the question asks you to find acceleration in X, acceleration in Y, and then the question asks you to find the resultant of A. So basically this one relate with the working step of the vector. So please go back to vector and make sure that you know how to find a magnitude and direction. Okay, so this one is basically pretty easy. The question just asks you about finding a net force. And then for the question A, 1,000 kilogram car at 1/2g. So definitely you need to use only F equals to MA, and then just insert your mass, make sure that it's always be an SI unit, because you need to understand that force in Newton is basically kilogram meter per second square. That's why I encourage students to make sure that please change into SI unit. Okay. Okay, so that is question A and B for the first one. And this third example, force to stop a car. What average net force is required to bring a 1,500 kilogram car to rest from the speed of 100 kilometer per hour within a time the questions give it to you. Okay, I think there's something missing here. Okay, so definitely for this one, you need to find acceleration first. Once you find acceleration, then you can actually find the force. So the question already give you from rest, which is your V not going to be 0. And then this one, please change into meter per second. And then you can actually find it using V equals to V naught plus AT. There's a missing word here. Okay, so once you find the acceleration, definitely you can find the average net force. Okay, you can actually refer this full question in slide. Okay, sorry for the problem here. Okay, so this question, okay, let's solve this question together. Okay, so an airboat with mass 3.5, power of 2 kilogram, including the passenger, has an engine that produces a net horizontal force of 7.7 power of 2. After accounting for force of resistance, find the acceleration of the airboat. So this one going to be very easy. The question already give you net horizontal force, and the question already give you mass, so you can actually just use F equals to ma. Okay, starting from rest, how long does it take for the airboat to reach a speed of 12 meter per second? Okay, so you already got the acceleration from the first question. Okay, so you can use the kinematics question. So basically, mostly for the Newton's law, the question is going to be related with kinematics, where you need to apply the equation of V equals to V naught plus AT, V square equals to V naught square plus 2A, Y S minus S naught, or S minus S naught, V naught T plus half AT square. So for this one, I think once you got the acceleration, the question asks to find how long. So you can use V equals to V naught plus AT. Okay, and question C, after reaching the speed, the pilot turns off the engine and drift to the stop over a distance of 50 meters. Find the resistance force, assuming it's constant. So what happened here is you need to find the resistance force, which means that you need to find first the acceleration. Okay, so now the pilot turns off the engine, so you can actually use V square, V naught square plus 2A, S minus S naught. Okay, so V square definitely going to be 0 because it's come to a sudden stop, and V naught square going to be 12 square plus 2A, 50 minus 0. Okay, so you are going to get your acceleration is negative, which means that it's going to be decelerate. Okay, and then from here you find F equals to ma. Then you are going to get your force is going to be, okay, this answer you are going to get negative is because it's a resistant force, which means that the one that going to oppose the motions, and yes, it's going to be negative. Okay, so let's proceed to the next one. Okay, I already show you the working state. You can double check your answer with this one. Okay, make sure that you take care of the units, make sure you show the formula. Okay, and then if you get negative, please give some reason over there. Okay, it's moving to the left or decelerate or something like that. Okay, so we move forward with the Newton's third law. Okay, so Newton's first law is the inertia, second Newton's law is about F equals to ma, and the third Newton's law is about action and reaction. Okay, action and reaction, but it's not complete words. Okay, you need to like specifically give the definition of Newton's third law. So you can actually use, if you have like one object, okay, one object, and this object exert force to the second object. Okay, so for example, A exert force to the B, so B going to exert force with the same magnitude but different direction. Okay, and that is the first law. That is the first rule when it comes to Newton's first law. So you have the same when you apply force. Example, if you apply force to the wall going to apply force to you with the same magnitude, different direction. That is the first rule. Second rule, when it comes to Newton's first law, in the force that you exert, force exert on different object. Okay, example. You walk in front. So when you want to moving forward, what happen is you are going to apply force to the ground, right? Okay, so ground, and this is you. Okay, so you apply force to the ground backward. What happen is ground going to apply force to you inward. So it means that you are going to move forward. Okay, so if I put it in words, you can actually see that this second rule where force exert on different object. Okay, you exert force to the ground. So means that the one that going to feel a force is ground. Okay, and then because of Newton's third law, ground exert force to you. So so the object that going to feel the force is you. So you can actually say that is exert on different object. Okay, so you exert force to the ground going to feel the force. Okay, and then ground exert force to you, so you feel the force. So that is the reason, that is the second rule that you need to put it in your mind, where when it comes to Newton's first law, it need to be exert on different object. Okay, if example you see that both force exert on the same object, then it means that it doesn't apply the concept of Newton's third law. So everything comes together, everything comes in pair. So example, if you exert force to the wall, so wall going to feel the force. Okay, and then the wall going to exert force to you, so you are the one that going to feel a force. So basically it comes in pair. That is the second rules for Newton's third law. Okay, so everything that happens here, basically what happened in your everyday life, you basically apply Newton's third law. You sit on the chair, so you apply force to the chair going to apply force to you. So everything comes in pair, action and reaction, same magnitude, different direction. Okay, so like this. Okay, whenever one object exert a force on a second object, the second exert an equal force, which is equal in terms of what? Magnitude. Okay, but in the opposite direction on the first. Okay, so this is the first one. The second one going to be, it needs to be exerted on different object. So here also prove that when you apply, your hand apply force to the desk. Okay, so force exert on desk by hand. Okay, so desk going to be the one that feel the force, and because of Newton's third law, desk will apply force in the opposite direction to you, to your hand. So you can see that what happened is the one that going to feel the force is different object. One is desk, another one is hand. Okay, so make sure that you put that the second rules. Okay, please do not avoid the second rules. Okay, so this is another conceptual questions where the question asks you to find what is it the force to move a car. Okay, basically car is moving because of the engine, but another thing that makes the car moving is because the tire push backward against the ground. So the one that going to feel the force is ground, and because of Newton's third law, ground will exert push force to you forward. That's why the car can move forward. Okay, because of this concept of Newton's third law. Okay, so when it comes to the subscript, it's basically the way of you to write for the force of for the Newton's first law. Okay, what happened is the first subscript going to be the object that the force is being exerted, which means that the one that going to feel the force. The second is the source of the force. So example for this one, you apply force to the ground. So it means that ground going to be the first one and you going to be the second one. The first one is the who basically feel the force. The second one is going to be source. Okay, means that if you apply force to the ground, okay, definitely ground going to apply force to you, so it's going to come in the same magnitude but different direction like this. Okay, so you make sure that you know how to write a proper subscript when it comes to Newton's first law. Okay, but for your questions, mostly we are going to find the force exerted, means that you are not going to find you exert force to other object. Mostly for the questions, you are going to find the net force acting on you, means that all the forces acting on you. Okay, if you need to find the force acting on the other object, then the question is going to change a little bit. So it means that the main focus here, the main character here going to be another object. Okay, so when it comes to the Newton's law, make sure that you recognize, identify which one is the main character of the object, main character of the calculation. Okay, so like this one. Okay, a man of mass m 75 kilo and a woman of mass 55 kilo stand facing each other on ice rink, both wearing ice skate. The woman pushed the man with horizontal force of 85 Newton in the positive x direction. Assume the ice is frictionless. What is the man acceleration? Okay, so you can just use F equals to ma. Okay, because the woman pushed the man with horizontal force of F 85 Newton, which means that basically when it comes to the Newton's first law, woman push 85 Newton, which means that the man will push with the same magnitude but in different direction. So you can actually find the acceleration from there. What is the reaction force acting on the woman? Okay, the question asks you to find the force acting on the woman, which is the man going to push the woman negative 85 Newton to the left. Calculate the woman accelerations. Okay, you already have the force. Okay, you already have the force acting on the woman, which is negative 85 Newton, and then you have mass of the woman. So the acceleration here you are going to get negative, which means that it's going to move to the left, which is negative x direction. Okay, so everything comes in pair. If you apply 85 Newton to the wall going to apply to you 85 Newton but different direction. Okay, so I already show you the working step at the back, so please double check the answer. Okay, and then please give the reason why your answer is negative, because of is moving to the left, which means that moving to the negative x direction. Okay, let's move forward with the second part. So the second part going to be focused on the FBD, free body diagram. Okay, so you already go through the concept of Newton first, second, and third. Now we are going to apply that in our calculations. Okay, so let's start. Okay, so here we are going to focus only on two forces, which is weight and normal force. Okay, and then after that we are going for the tensional and also the application in the inclined plane. Okay. Okay, so when it comes to the weight, okay, weight going to be related with the gravitational acceleration. So yes, you can see that what we learned before, acceleration is always downward. So your mg also downward. This is what we call as a gravitational force, or the other name is weight. Okay, so that's why you are going to use F equals to mg. Okay, please do not confuse between gravitational acceleration and gravitational force. Okay, but both are going to be in the downward direction. Okay, so okay, normal force is the other name for contact force. So means that if you put one object on the table, okay, so what happening is if this object is your main character, that's why I said before, please make sure that you identify which one is your main character, which one is the question that you need to, which object that you need to focus on. Okay, so example, you have table and then you have one box. So this table going to apply normal force perpendicular to the surface. It should be perpendicular to the surface. It cannot be parallel. It cannot be vertical. It cannot be horizontal. The answer going to be perpendicular to the surface. That's the reason why we call normal force as a contact force. Any contact with the object, definitely you are going to have a normal force. Example, if the object hanging without contact with the surface, it means that there will be no normal force. Okay, so example, there's one misconception when it comes to this situation. Okay, so the misconception is where, okay, example, if I put one box on top of the table, okay, and then this box at rest. Okay, so when it comes to at rest, it means that your normal force, which is normal force, come from the table acting on the box, and then you have a gravitational force acting downward. So when you say that this object at rest, it means that your normal force equals to your gravitational force, which means that they have the same magnitude but different direction. Okay, one is upward, one is downward. But most of the students state that this situation will apply concept Newton's third law. But as you can see that this situation of the question doesn't apply Newton's third law. Yes, it's going to have the same magnitude, different direction. But like I stated before, second rule when it comes to the Newton's third law, it need to be acting on different object. Okay, example. Okay, I'm going to put it in the sentence to show that why this situation doesn't apply concept of Newton's third law. Okay, so the normal force is contact force, which means that table exert force to the box. Okay, so the one that feel the force is going to be box. Okay, and the gravitational force over there, gravitational force is basically come from Earth. So Earth exert force to the box, which means that box also feel the force. So does it mean that it applies Newton's third law? Definitely no, because both object that feel the force is box. Go back to the second rules. The force need to act on different object. Okay, so this one, even though it at rest, yes, it's applied the first one, which is same magnitude but different direction. But you need to make sure that when it comes to Newton's third law, you need to apply both rule, which is another one is acting on different object. So how to fix this word to make sure that it becomes Newton's third law? Okay, so when it comes to the Newton's third law, okay, you can actually fix this statement by, okay, table exert force to the box. So Newton's third law come in pairs, which means that table exert force to the box. So box exert force to the table. This is Newton's third law. This one and this one. Okay, because acting on different object and comes in pair. Okay, and how about gravitational force? Okay, Gravitational force come from Earth. Earth exert force to the box. So another statement to complement this one going to be box exert force to Earth. Okay, but Earth not going to like moving because box is like very very small. So this one and this one comes in pair, and this one is third Newton's law. Okay, but when it comes to the calculation, mostly we are going to find the force exert on the main character. So that's the reason why we don't have to draw the directions for box exert force to the box and box exert force to the Earth. Okay, because the main character now is box. Okay, that's the reason why you only find a force exert on the main character, which is the main character now is box. Okay, so if you need to put it in a statement, it means that table exert force to the box, which is this one, and the box exert force to the table, so it's going to be in that direction. Okay, and the first and the second one is the Newton's law, same magnitude, different direction, and acting on different object. Okay, and for the second part, which is gravitational force, Earth exert force to the box. Okay, means that Earth going to exert force to the box downward. Okay, which because follow the direction of gravitational acceleration, and box exert force to the Earth. Okay, it can be anywhere because Earth is like so large and box is like very very small. Okay, but it also comes in pair, and that is Newton's law. Okay, please make sure that you didn't confuse. Okay, and make sure that you fully understand how to apply Newton's law. Okay, this situation doesn't apply Newton's law. Accidentally you have the same magnitude, different direction at rest, but it doesn't apply second rule, which is acting on different object. Okay, understand? Okay, that's why please go back to the rules of the Newton's law and try to apply to the concept of the questions. Okay, so this is the one that I already mentioned before. So what happened here is this statue at rest, and you have the gravitational force and normal force. So means that you can actually say that the normal force equal to the gravitational force. But this one doesn't apply the Newton's law because it acting on the same object, which is statue. Okay, but to fix it, to make a statement, then you need to give like table exert force to the statue, then the statue going to exert force to the table. That is going to be Newton's law. Same goes to the gravitational force. Gravitational force come from Earth. Earth exert force to the statue, means that the statue will exert force to the Earth. Okay, and that is Newton's law. Okay. Okay, so you have a questions in front of you. Okay, so when it comes to the Newton's law, the first thing that you need to do is you need to draw the FBD. Okay, the free body diagram, or we call as a force body diagram, which means that you show all the forces acting on that object, acting on that main character, which is now your main character is a box. Okay, so when you have a contact, when you on the surface, definitely you are going to have a normal force. Always be perpendicular, not vertical, not horizontal. Okay, so you have one box which is basically on top of the table, so you have normal force going upward, and anything and all the object in this world definitely going to be acted by the gravitational force, which is going to be downward. Okay, so this one, the question asks you to find, determine the weight of the box and the normal force exerted on it by the table. Okay, so for you to find the weight of the box, definitely you are going to use mg equals to mg. Okay, so your m going to be 10, so times 9.81, so you are going to get 98.1 Newton. Okay, basically very easy. So if the question asks you to find the normal force, because this object doesn't move, so it means that it should be Fn minus mg. Supposedly it should be equals to ma, but because it doesn't move, then this one going to be 0. So your normal force will be equals to your gravitational force, which is 98.1 Newton. Okay, okay, let's move forward with the next one. Sorry. Okay, Now your friend pushed down on the box with a force of 40 Newton. Again, determine the normal force as a on it by the table. Okay, definitely first thing first, draw. You have normal force upward, you have mg always acting downward, and then your friend pushed down, so means that the applied force going to be like that. This is the push force downward. So the question asks you to find normal force, so means that now the equation going to be Fn. Okay, please make sure that you need to assign your direction. If you assume downward is positive, then you put the positive. If you assume downward is negative, then you put it as negative. So now I assume that upward is positive, downward is negative. So it's going to be Fn minus mg minus Fp equals to what? Ma, but it doesn't move in particle, so that's why you're going to get 0 over there. Okay, so Fn minus mg minus Fp, therefore the question asks you to find Fn, which means that Fg plus Fp. So 98.1 plus with the 40 Newton, then you're going to get 138.1 Newton. Okay, so make sure that you start with the FBD first, free body diagram, then you come up with the equation. Okay, next one. If your friends pull upward, okay, your friends now pull upward on the box with a force of 40 Newton, what now is the normal force? So first thing first, draw the FBD, Fn, upward, mg always downward, and now your friends pull upward. Pull upward, so means that he's going to be, okay, so I move this thing a little bit. Okay, so your friends pull upward, so this is going to be Fp. Okay, if your friends hold like cord or rope, then you put the Ft, tensional force. Okay, so now the equation is going to be Fp plus Fn minus mg. It doesn't move upward, right? So it's going to be equals to 0. So your normal force will be mg minus Fp 90.81 minus 40, so you are going to get 58.1 Newton. Okay, pretty easy, right? Okay, that's why it's better for you to come up with the FBD and then come up with the equation. Please make sure that don't put again negative in your G, because you already give the direction which is you assume downward is negative, that's why you put negative here. Okay, don't put G negative 9.81, okay, because it's redundant. Okay, so this one, what happens when a person pulls upward on the box in the previous example with a force greater than the box weight, say 100 Newton. So now this person pulls more than the weight of the box. So what happens? Yes, very good, it's going to pull upward, so the object will definitely lift up. Okay, because the pull force is larger than your gravitational force or weight. Okay, so means that what happened here is when you pull this thing upward, you are not in contact with the surface. It means that your normal force equals to 0. Okay, because normal force is a contact force. Anything that comes into contact, then you put it as a normal force. Okay, so another questions for the Newton's law is going to be inside the leaf. Okay, so the question asks you to find, during this acceleration, what is her weight and what does the scale read? And the scale basically read in kilogram. Okay, so the first thing first, draw the FBD. Okay, so this woman standing on the scale, so this scale give this woman normal force upward. Okay, and this woman have mg, and then now you are basically moving downward. Okay, so to be safe and to avoid careless mistake, please make sure that you choose your positive depends on the acceleration. If your acceleration moving downward, so anything that follow the direction of acceleration, just put it as a positive. Okay, it's much safe and you can avoid careless mistake. Okay, so now because my mg follow my acceleration, So what happened is mg going to be positive and fn going to be negative. Okay, so the equation going to be mg minus fn come from scale acting on the woman equals to me. Okay, what is her weight and what does the scale read? So the question asks you to find normal force, because scale read in kilogram and scale apply normal force to the woman. Okay, so you are going to get fn, which means that it's going to be mg minus me. So the woman is 65, 9.81 minus your acceleration, which is 0.20 g. G is gravitational acceleration, just put it like that, and then you are going to get the answer is 510.1 Newton. Okay, so if the question asks you to find scale read in kilogram, which means that you need to divide by 9.81. This is weight or gravitational force, so divide by 9.81. so this woman, the weight going to be reduced to 52 kilogram. This mass we call as a apparent mass. Okay, so what happened is you are going to feel light, or your weight going to be reduced if acceleration is going to be downward. You are going to feel heavier if your acceleration moving upward. So basically what happened is because of the me, the one that reduce your weight or you feel heavier is because of the acceleration. Okay, if you stay at rest, it means that you are going to have your weight not going to be changed. Okay, so the one that change your weight is going to be your me. That's what we call as the apparent mass, or to be proper we call as the apparent weight. Okay, so what does the scale read when the elevator descend at the constant speed of 2 meters per second? So when you put the constant speed, it means that your acceleration is going to be 0. So based on the equation itself, and they state descend, so mg minus fn equals to ma. Because it's constant speed, then this one going to be 0. So means that the scale going to read the same weight, which is the same mass, which is 65 kilogram, or in Newton is going to be 638 Newton. Okay. Okay, so what if you, example, someone cuts, or you fall like a free fall. Okay, so example, someone cuts the cord or someone cuts the rope of the lift. So what happens is you are going to fall with the gravitational acceleration, which is 9.81 meter per second square. Okay, so this is what I mentioned before, the free body diagram, which means that you need to separate that into components, which is fx and fy. Okay, because force is vector. So for you to solve this kind of questions, definitely you need to separate that into the components, find the resultant of force, or if the question asks you to find the resultant of acceleration, just find the resultant of force, which is the magnitude, fx squared plus fy squared. Okay, and then if the question asks you to find the resultant acceleration, just use the value from the resultant force equals to me. Okay, then you are going to get the resultant acceleration. Okay, right, so basically very easy. Okay, okay, this one, a hockey puck is sliding at a constant velocity across a flat horizontal ice surface that is assumed to be frictionless. Which of these sketches is the correct free body diagram for this puck? Okay, it's sliding at a constant velocity and is assumed to be frictionless, which means that we didn't have to put friction. So between number 1, number 2, and number 3, which diagram represent the situation of the questions? The answer going to be yes, number 2. Okay, because the question state frictionless, so means that there's no friction at the surface, and it's sliding at a constant speed because of what? Fn equals to mg. Okay, for the first one, you apply force, you continuously apply force, that's why you are going to move forward. Okay, but the third one going to be you move this force is opposite to the motion, so this is basically a FFR, which is friction force. Okay, so what will your answer be if the park slow down? The answer going to be number 3. Because why you slow down? Because there's something that opposes the motion, which is frictional force. Okay. Okay, now, okay, we are going to draw the FBD for this object where you have Fy and Fs. So means that you need to separate that into components. Okay, so you have one object and there's someone actually pulls with some angle of 30 degree. Okay, so basically every object have mg, and then you have the normal force come from the surface of the table. Okay, so the question asks you to find the acceleration of the box. So please take note, separate that into component first, which is going to be Fp cos theta. This one going to be Fp sine theta. Okay, so for the y component, okay, we need to come up with the equation. You are going to get Fn plus Fp sine theta minus mg equals to 0, because it doesn't move in the vertical direction. Okay, okay, and then for the x component, the equation is going to be, okay, you moving forward, you moving the horizontal, so means that the equation is going to be Fp cos theta equals to me. Okay, and the question asks you to find acceleration. Okay, so the Fp is 40, so means that 40 cos theta is 30 degree divided by the mass is 10 kilo, then you are going to get the acceleration, which is 40 cos 30 divided by 10, you are going to get 3.46 meter per second square. Okay, the magnitude of the upward force, which is normal force, exerted by the table. Even though I didn't mention normal force, you need to know that the one that apply force to the box is going to be normal force, or the other name is contact force. So we are going to use this formula that we derived for the y component, Fn plus Fp sine theta minus mg equal to 0. So for you to get Fn is going to be Fp sine theta, the negative Fp sine theta plus mg. So negative 40 sine 30 plus 10, 9.81. So you are going to get the answer is 78.1 Newton. Okay, so when it comes to force, please make sure that you separate into component, y component and x component. Okay, and definitely draw the FBD, the free body diagram. Okay, okay, so now we move on with another force. Okay, before this we discussed about gravitational force, we discussed about normal force. Now we discuss about tensional force. Okay, when it comes to the tensional force, the things that you need to understand here is, if example, the cord or the rope doesn't the cord or rope negligible mass, it means that the tensional force will be distributed equally. So it means that at this side and at this side will feel the same force. Okay, if the question state the cord or the rope negligible mass, tensional force will distribute equally. Okay, but if example your rope or cord have a mass, tensional force Ft1 doesn't equal to the Ft2. Okay, because it's going to attach to different object, and we can actually say that as if this one is the another object. Okay, I can actually put it like this. Okay, you have object A, you have cord that have a mass, and then you have B here. Okay, so when it comes to this, the way you draw the FBD going to be, you assume that this is like another object. We put it at the C. So the free body diagram for A going to be FT object A acting on chord. Okay, and then you have the normal force, and then you have the gravitational force. Okay, and then if the question frictionless, then you don't have to put the friction. Okay, this is for object A. Okay, you come up with the free body diagram for the object B. Okay, you have normal force, you have MBG. Sorry, I need to put the subscript here. Okay, and then you have chord that have a mass, so you put as a tensional force B acting on the chord. Okay, and for the chord, because it have a mass, so you can assume that it's like another object, which means that at this side is going to apply force FTC, apply force to the object A, and at this side it means that the tensional force FT apply from C to B. Okay, and then you can actually say that FTBC equals to FTCB, which means that FTBC is the negative because moving to the left, and equals to the FTCB, Newton's first law. Okay, and the FTAC equals to FTCA. FTAC equals to negative FTCA. Okay, Newton's first law at the same magnitude, different direction. Okay, so you can assume that rope, if example the rope has a mass, so you can say that it's like you have one object. This is B, this is C, and this is A. Okay, but if there's no mass or negligible mass, the tensional force here and the tensional force on the other side equal. Okay, so first thing first, when you see the questions, please double check whether the chord has a mass or chord doesn't have a mass. Okay, if the chord has a mass, you put it as if there's another object. Okay, and if it doesn't have mass, negligible mass, it means that the tensional force is going to be equal for both sides. Okay, so this object, okay, example, okay, the question asks you to find the acceleration of the box and the tension in the cord connecting the box. Okay, but this one, the two boxes A and B are connected by a lightweight cord. So when the question state lightweight cord, it means that negligible mass. Okay, and are resting on a smooth table. The box has a mass of 12 kilo and 10 kilo. A horizontal force of 40 Newton is applied to the 10 kilogram box. So when it comes to this kind of question, definitely FBD is very important. So we are going to draw for the object A first. Okay, so you have pull force. Okay, and then definitely you are going to have normal force, and then you are going to have the gravitational force. Okay, and then you attach to the cord, which is lightweight cord, which means that when it comes to lightweight cord, tensional force for this side and for this side going to be the same value. Okay, this one and this one have the same tensional force. Okay, so make sure that you put FT here also. Okay, like that. Okay, and this is object A. What about object B? Okay, object B, okay, you have tensional force, and then you have Fn, and then you have Mg. Okay, so you don't have the FP for the second object because FP apply to the MA. So the one that makes sure that the object B move forward is the chord and the MA. Okay, not FP at, please don't draw FP at second object because you apply force to the A, you didn't apply force to the B. Okay, so make sure that you double check the FBD first before you proceed with the equation. Okay, so the question asks you to find the acceleration of each box. Okay, so because it's okay, if your chord didn't break or taut, okay, so what happened is your acceleration is going to be the same for both objects. Okay, if your rope or cord didn't break or taut, so means that you are going to have the same acceleration for both objects. Okay, so for us to find this, definitely we need to come up with the equation. So I'm going to come up with the first one from the object one. Okay, so like I mentioned before, anything that follow the directions of the movement, put it as a positive to be safe. Okay, so the one that going to follow the movement going to be FP. Okay, so this one, it means that you're going to get your equation is FP minus FT equals to MAE. Okay, please come out the equation for that particular object. So if you put A, if you come up with the from the object A, then put your mass as MA first. Okay, then after this we are going to combine. Okay, it's much safe and it's easy for you to understand instead of you just combine all the object into one object. Okay, okay, and then you have the object B. Okay, so FT equals to MBA. Okay, so what happened is because the object because the chord doesn't break, so you can actually put the FT here because it's going to have the same value. So you're going to have FP A minus MBA equals to MAA. So for you to find the acceleration, which means the FP MB plus MA acceleration. So you are going to get your acceleration is FP is 40, MB and MA is both 10 and 12. 10, 12 plus 10. So you are going to get your answer is 1.82 meter per second square. Okay, okay. And the question asks you to find the tension in the cord connecting the box. So you can actually use the first one. You can use the box from the box A, or you can use from the box B. Okay, because both have the same tensional force for the cord or rope that doesn't have any mass. Okay, if example your cord or rope have a mass, then your tensional force is going to be different. Okay, so I'm going to use the FT equals to MBA because it's very short, so it's much easy. So FT equals to MBA. I already have the acceleration, so my 12 times 1.82. So supposedly I'm going to get the answer 12 times 1.82. I'm going to get 21.84 Newton. Okay. Okay, that's how you do it. Okay, so the easiest way is you need to separate the FBD for both object. If you have 3 object, then you have 3 FBD, free body diagram. And then if you have 3 object, it means that you are going to have the 3 equations. So now we have 2 object. That's why I've come up with the first equation for this one, and then it's going to be the second equation for this one. It's much easy. Okay. Okay. So example for this object. Okay, for this question, sorry. We have different acceleration. One is going upward, one is going downward. Okay, so the question asks you to find the acceleration of the elevator. Like I mentioned before, anything that follow the acceleration, just put it as a positive. But for this kind of questions, because we have acceleration in different direction in one situation, so you need to assign which acceleration that you need to put as a negative, which acceleration that you need to put as a positive. Okay, so I'm going to put upward as a positive and downward as a negative. Okay, okay. So definitely first thing that you need to do is FBD. So for the counterweight, okay, because the question state that over a pulley by a flexible car, and then the questions flexible cable, yeah. Okay, mostly for the questions we are going to state the cord has a mass or cord doesn't have a mass. But this one, the cord doesn't have mass. Okay, okay, if the cord have a mass, it's going to be quite complicated questions. But this one doesn't have a mass. But in your exam question, definitely we are going to state whether negligible mass or not. Okay, okay, and then it doesn't stretch, it doesn't break, so your tensional force for both sides are going to be the same thing. So for the counterweight, your tensional force, please take note, tensional force always be outward. Always be outward from the object. Okay, always be outward from the object. And this has a gravitational force. Okay, and then you have the elevator, FT, which is basically the same thing. It's the same FT with the counterweight. And then you have her MEG to represent gravitational force for the elevator. Okay. For your reminder, for your attention, it's better for you to draw the directions of acceleration. Okay, so this is elevator going to be downward. this one going to be output. The reason why I ask you to put this is because to be extra careful when it comes to put the sign negative and positive. Okay. Okay, so the equation for the counterweight, this is counterweight, this is elevator, going to be if I assume output is positive, Ft minus mcg equals to mca. This is going to be the first equation. Okay, and I put it as a Ft as a subject because after this I'm going to substitute that into the second equation. So mca plus mcg. Okay, so for the second one, which is the elevator, the equation is going to be Ft minus meg equals to negative mea. Okay, because I assume one acceleration is upward is positive, one acceleration downward going to be negative. Okay, so for this one, I'm going to put the Ft equals to mca plus mcg into this equation. So I'm going to get my combination equation going to be mca plus mcg minus meg equals to negative mea. So it's very important if you put the subscript to differentiate which mass represent for the object. Okay, so you are going to get here is so the question asks you to find the acceleration, so you put acceleration at one side, so you are going to get, okay, mca plus mea equals to meg minus mcg. Okay, so for the question asked you acceleration, just factorize, so you are going to get mg equals to me minus mc plus m over mc plus me. So this one you're going to get 9.81. Your mass for elevator going to be 1150 minus 1000, so 1150 plus 1000. Okay, so you're going to get 0.684 meter per second square. Okay, okay, next is the question asks you to find the tension. So you can use equation from the elevator or equation for the counterweight, because both have the same tension of rho. You can use this one or you can use this one, it's up to you. Okay, okay, so I'm going to use the first one because I already put it Ft as a subject. So my tension going to be tension of force Ft equals to mca plus mcg. So mc like a plus g, so my counterweight going to be 1000. Acceleration is 0.684 plus with the 9.81, so you are going to get for this one to be 1.05 power of 4 Newton. Okay, okay, as simple as that. Okay, that's why it's very important for you to come up with the equation, because it's much easy instead of you just combine everything in one object. Okay, okay, let's move forward to the last part in the Newton's law, which is inclined plane. So when it comes to the inclined plane, definitely you need to resolve into components, which is x component and y components. Okay, so example, if you have like one inclined plane, okay, like this, and then you have like one object standing on the inclined plane, please make sure that you come up with the force first, the FBD. Okay, so this box on top of the inclined plane, definitely you are going to have normal force, which is perpendicular to the inclined plane. Okay, and then you are going to have mg that always be vertical. Okay, the gravitational force always be downward and vertical. Okay, so now to make it easier, you need to change your axis a little bit, where your axis now become, this is your y and this is your x. Okay, if you want to tilt, if you want to put it as a this is y and this is x, you can actually do that, but it's quite complicated when it comes to the certain questions where the students might get confused. So I'm encouraging students to choose this axis as your Newton's law axis. It's much easy, okay, and it's avoid careless mistake. Okay, so if your axis like this, so what happen is you are going to resolve mg, okay, into x component and y component. So you are going to get, here is mg, okay, we are going to put as a cos or sine, and this is mg. Okay, so how to decide which one is cos, which one is sine? Mostly the question going to give your angle horizontally, which is the angle of the inclined plane. So for you to get your angle, for you to use your angle here, is going to be the angle at, I'm going to draw it back to make a proper picture of this. And this is inclined plane. You have an object here. This is your normal force. This is your mg. Okay, example, if I put it like this. Okay, this is your mg, we didn't know yet, and this is the mg. Okay, example, if your angle here is 30 degree, okay, so you can see that from this is 30 degree, so you have like one triangle. This is 30, so this is 90, so definitely this one going to be 60, right? Okay, so this one going to be 60 degree. Okay, so as you can see that this one is 90 degree. So example, this is 60, so means that this one going to be 30. Yes, that's how you find the angle. Okay, so means that 30 degree that given by the inclined plane will be 30 degree that touch y-axis. Okay, so for this one, if you choose to use 30 degree that touch y-axis, so this one going to be mg cos 30 degree, this one going to be mg sine 30 degree. Okay, if you want to use 60 degree, yes, you're allowed to use that. Okay, but this one you need to change into cos 60 degree, this one you need to change into sine 60 degree. It's going to give you the same result. Okay, but for me, I'm going to use the angle of the inclined plane, therefore my y component going to be mg cos theta, and my x component going to be mg sine theta. Okay, so this one we are going to complete the drawing for this one. So this one going to be mg sine theta, this one going to be mg cos theta. Okay, so once you finish already the diagram, then you need to come up with the equations, separate that into x component and y component. So you have x component, if from this one, x component going to be example is moving downward. Okay, example, the box moving downward. So anything that follow the direction of acceleration, just put it as a positive. Okay, so you are going to get mg sine theta equals to ma. Okay, that's going to be x component, and for the y component is going to be fn minus mg cos theta equals to 0, because it doesn't moving upward. Okay, and separate that into the components. Okay, if example you have object something like this, okay, like example, you have inclined plane, okay, and then you have one object attached to the you have tensional force attached to this one hanging object B. Okay, so now we are going to learn how to draw the FBD. Make sure that you separate that into components, okay, into object. Okay, so the object B, so you have object B. Please take note, your tensional force always be outward from the object, and then definitely you are going to have MBG. Okay, for the object A, how to draw that? Okay, so you're going to have one inclined plane. So example, the question give you the angle here, so you have definitely you're going to have normal force, then you are going to have mg, which is vertically downward. Separate that into components, which is this one going to be mg cos theta. I'm using angle that touch I'm using angle of the inclined plane. Okay, so this one going to be mg sine theta, and definitely you are going to have tensional force over there. Okay, because the cord or the rope doesn't stretch or break, then the tensional force is going to be the same thing. So if the question asks you to find the acceleration, example, we Okay, if your object B, mass of object B more than mass of the object A, sorry. So your acceleration going to be like this and like this. Okay, so please take note, anything that follow the direction of acceleration, just put it as a positive to make sure that you avoid careless mistake. Okay, so we come up with the equation for this one first. So my mbg will follow the direction of acceleration, so I'm going to get mbg minus ft equals to mba. This is going to be my first equation. Okay, so for the object A, so for the object A, okay, I separate that into components first. Okay, I'm going to find the y component first, which is going to be fn minus mag cos theta equals to 0 because it doesn't move upward. Okay, and for my x component, because my ft follow the direction of acceleration, so my ft going to get positive. Okay, so it's going to be ft minus mag sine theta equals to mee. Okay, so if the question asks you to find the acceleration, just put this equation or this equation with the ft as your main subject and just substitute. Okay, and that's how you do it. Okay, so make sure that when it comes to the question, please make sure that you draw completely your FBD and make sure that you separate that. Okay, draw separately for the object and then come up with the equation separately. For the object A, come up with the x component, come up with the y component, and the object B, if they have only y component, just come up with the y. And if you have the both inclined plane, then you need to have x and y for both object. Okay, and that's how you do it for the inclined plane. Okay, I think that's all for now. After this, we are going for the frictional force, where we are going to add up another force in our FBD, which we are going to discuss that for the next chapter. Okay, so feel free to ask me any questions, and I'm going to see you for the next chapter. So thank you very much, and assalamualaikum and bye bye.